Renderworks cameras are an easy way of creating and saving a particular perspective within your document. It behaves similarly to a real camera, allowing for the control of position, direction, focal length, rendering mode, and other parameters. Unlike, say, views that are designed to be used as navigational tools, Renderworks cameras are primarily used for presentation purposes. Renderworks cameras are only available to users with the Renderworks module. To place a Renderworks camera, click on the tool in the Visualization palette. Then click once in your document where you wish the camera to be placed. If you do not snap to any 3D geometry, the camera will be placed at approximately the height of a person in relation to 0, around 1.5 meters. The second click will determine what the camera is looking at initially. Both of these set locations can be easily altered afterwards. In top plan view, you should see this graphic appear, representing the Renderworks camera along with a few of its parameters. The selection handle that appears where your first click was will control the XY location of the Renderworks camera object itself. The selection handle appearing where your second click was controls where the camera is pointing at. Again, in top plan view, this is X and Y only. In addition to these selection handles, you'll see two others. There'll be one along the arc in the middle of the graphic, controls the view angle, which expands or contracts the field of view. The final control handle will determine where the name of the camera will appear in 2D. Many of the settings for the camera are available directly in the Object Info palette. The name itself can either be changed in the Data tab of the camera's Object Info palette or near the bottom of the Shape tab under Camera Name. If you're going to include multiple Renderworks cameras in your document, it's a good practice to name it something related to the view it represents for easy identification. Rotation controls the direction the camera is pointing, similar to other planar objects, but this is normally controlled by the direction selection handle rather than this field. Camera height controls the height of the actual camera object itself. Your perspective when using this camera will be from this height. Look to height is essentially the tilt of the camera. Increasing it will raise the camera's views up, and decreasing it will tilt the camera view down. However, it's not relative to the camera height, so if you have to look to a height of 2 meters, and the camera height is at 1 meter, the camera will be looking upward. If you change the camera height to 10 meters, but leave the look to height alone, the camera would then be pointing downward. Top Plan View button will immediately switch your view to top plan and focus in on the camera object's 2D graphic. Activate and deactivate camera. This button will change your current view to match that of the selected camera. Once active, moving around with the flyover or walkthrough tool will continually modify the camera's view. It locks the camera to your view directly and will stay that way until you click Deactivate Camera, or if you enter one of the standard views like Top Plan. Match Current View is the inverse of Activate Camera. It will cause the selected camera object to match itself to your current view. Click to Aim Camera will cause the next click you make within the drawing area to attempt to focus the camera on that point. This is best used in OpenGL or another render mode where you can see solid surfaces, since in wireframe it can be hard to tell what's what, but it will work in any render mode. Fine-Tune Camera View will bring up a dialog that allows you to finely control the camera itself directly. Camera height and look to height, these are the same as the settings available earlier in the Object Info palette. Camera Pan will turn the camera left and right while keeping it in place. Camera Move left and right will strafe the camera around the current direction that the camera is facing. It will not slide to the left or right in a straight line, but pivot around the focus point. Camera Distance controls how far the camera is from its focus point. Focal Length functions as a zoom lens, reducing the field of view in order to increase the detail of objects centered in the view. Perspective allows you to alter the perspective used by the camera, similar to a real camera using a wide or narrow angle lens. Render mode simply dictates what render mode will be displayed when viewing this camera view. If you set this rendering mode to something other than wireframe here, then use display camera view later on to return to this view, regardless of the rendering setting for the document that you were using before, it will switch to this rendering mode upon entering the view. When you've completed fine-tuning the camera view, make sure to click OK as cancel in this dialog will undo all changes performed with this mode active. Projection will determine whether the camera displays an orthogonal projection, which is what you normally see in 3D in Vectorworks using the flyover tool, or a perspective, where objects in the center of the view are clear, but objects to the sides will become distorted by the viewer's perspective, similar to the effect of vision in real life. Render mode, aspect ratio, and custom aspect ratio. All of these options are just duplicates of the one that was available in the fine-tuned camera view and behave in the same manner. For film size of, will determine the camera's film size as if it were a real camera, and will set the focal length automatically. DPI has no direct effect on the camera view, but it will control the resolution of anything exported while in that camera view. A setting of 72 is quick but relatively low quality, while 300 would be slower but very high quality. Pixel size will report the size of the camera's view area in pixels. This is determined automatically by the clip frame size combined with the DPI settings above. Left and right tilt angle will tilt the camera to the left or right, as opposed to panning, which turns the camera left and right. Tilt is mainly designed for matching a particular perspective angle. Negative angles tilt to the right, positive angles tilt to the left. Camera display controls how the camera object itself appears in 2D and 3D. 2D will only display a 2D icon. 3D will display a 3D icon, and 2D and 3D will show icons in both views. 2D plus name will show the icon and the camera's name if it has one, but only in 2D. 3D plus name will do the same, but in 3D views, and 2D plus 3D plus name will show all information about the camera possible in all views. In all of these settings, the name will only be visible in top plane. Auto Update 3D View, when enabled, immediately updates the view with each change to any setting of the camera. If this is disabled, the changes will occur all at once when the camera is updated manually afterwards. Auto Center 3D View will automatically center the view on the camera when Display Camera View is clicked, or when the camera graphic is double-clicked directly. Finally, viewports can be created directly from Renderworks Camera objects. With the camera selected, use View, Create Viewport, and then select to use the camera to create the viewport when prompted. At the very bottom of the Renderworks Camera's Object Info palette, you'll notice a section called Camera Effects, which are another more advanced method of controlling the artistic appearance of any renders made from this camera's view. These will be explained in detail in another video. Renderworks cameras are one of the most important tools for creating realistic renderings and achieving flattering angles. Knowing how to create and operate them is a big step forward in learning Renderworks.